Swayam Prabha. Digital India. Educated India.
So, we started with this course with this statement, right? That is the corrosion prevention control is a part of sustainable development, and there is a lot of importance in relation with the sustainable development because of the cost involved, and it's the loss of material resources and things like that in different sectors, and that way the corrosion control is important and things like that, right? So that's the kind of idea at which we initiated the course. Do you think that you got some extent this, at least an idea about different areas? Do you think that anything could have, you can openly tell that is some areas which could have covered. Of course, I cannot cover every area, that's the reason that I didn't do it, but some other areas are also important and things like that. That means you came to expecting that, okay, there will be some discussion on this area which was not there. Anything happened like that? No problem in openly telling. It's okay. It's because it's also an input for me. Anything like that? Talk. Huh? So you got something like you get an overview, right, of different things. So can we say that the course is successful? That sense? Yeah. So then I put together some of the things like which to just to get a kind of a glimpse of the thread what we did. So we start discussing about the corrosion theory, right? That's the basis at which we started, looking at from the thermodynamical point of view why the corrosion is happening and what are the thermodynamic factors involved. So we started from these fundamentals, and then we connected that to the electrochemical corrosion mechanisms, right? And we understood that how the electrochemical corrosion mechanism is different from the dry corrosion mechanisms. We understood the thermodynamic aspects related to it, and from there we took it to the kinetics part, right? Also understand that like there are these are the two important parameters in relation with the corrosion. One is on the potential side, determining the thermodynamic factor, and the current determining the kinetic factor. And then we understood that how the single electrode potential relate to each of the half reactions, and that becomes the building blocks or bricks to build up the electrochemical process, right? Basically that's what we do, right? These half reactions are the small bricks. So if the two bricks comes together, then you have a mixed potential like that, right? And then instead of two bricks, you can have three bricks, and then you have probably more additional cathode reactions. We say two bricks are related to the cathode reaction, one brick is related to anode reaction. What I mean is one half reaction is related to anode reaction, two half reactions related to cathode reaction, then you have a higher corrosion and things like that. So everything you can see that each of these point is a half reaction, and you can put together and stack it and understand, right? Theoretically. That's the main, this Evans diagram and like that. So that way we understood this theory part of the corrosion, and then we got into this little bit of a sustainability part, where we started first discussing about these coatings and chemistry of the environment, how that can be changed or the coatings. And in relation with that, there are many inhibitors used, and there are different coatings, but also the need for today is that to get this coatings into the green category. So that we discussed a little bit in relation to the inhibitors and also with the coating, right? That's what we did. Anything more on that? This is also the time to describe also if you do something more than, you also do something in this area. You can also tell that we also try to develop a coating like this. So this is also a time to, because that sharing the information for others also will be good. Any of you work with a green coatings or a green surface treatment? I think the Lashman's group, right? You work with, right? What kind of things you do? Self-healing type, right? So, yeah, yeah, yeah. You remember that we discussed about the self-healing type of coatings at the end. So that means that you are introducing the inhibitors into the paints. You can add the inhibitors. You can just mix the paint with inhibitors, but that's not good enough because then the inhibitor molecules will be immobilized. But when you are putting it in a more or less in a container, micro container, and putting it, then what will happen is when the micro container breaks because of the coating breaks, and then you have a mobilized inhibitor. I think this is the kind of solutions, right? That's what you are trying. Yeah, yeah. You also try the. You don't have to tell exactly what you are because probably it's also confidential. But you also try some green inhibitor chemistry or normal other inhibitors. Yeah, yeah. So you also want to include the green inhibitor inside the capsules and things like that, right? Yeah. So that's an example. As I think PhD project, right? So that's an example of such kind of things. I think that there are many universities people are trying to do like this. Only thing is nothing yet commercial, and because it's also require a lot of work. Anybody else is doing anything? Green coating, green conversion coating, and green inhibitors and like that. But this is an area which you can work. There is a lot of potential to work in that area, researching in that area. So anything more you want to know about that? Any questions related to that part? Yeah, as a part of this, we discussed with the green inhibitor, right? And we understood that it is, there is a lot of potential for the green inhibitor because all the natural extract contains this heterocyclic um, organic compound, but that is one of the criteria for this corrosion inhibition molecule. But the only thing is that it's too complex at the same time, right? Because all these extract contains many molecules. You can sell so many different type of extract, and that is one of the difficulty as well to work with these green inhibitors. So you have seen that we approach that from the molecular modeling point of view to as a screening method to these green inhibitors, which is probably a much more easy approach compared to doing the experiment. You can screen many molecules easily compared to doing the experimental way. But there is this green inhibitor, like what she was saying, like there is a lot of potential related to that, and also a good research area to work with. Then we discussed about the pre-treatment, right, which is one of the important thing because chromium has to be replaced, and nothing is there yet to substitute chromium. There are many coatings have commercially come up which people use, substituting the chromium like this titanium zirconium type of coating which people use today. There is a commercial Eclipse. I think the commercial name of that coating is called Eclipse, which involve this titanium zirconium composition, plus there is a polymer modifier in it. And so that means that when the titanium zirconium coating build on the surface, along with that this polymer also will deposit. So that when the titanium zirconium compound precipitate, so a little bit of this polymer also will deposit with that, and that way the coatings become better. So that's a commercial process is available, it's called Eclipse. Then permanganate is also a process which commercially available. I think it's Swedish patent, and a Swedish company doing it, and like that. So some alternative have come up, but nothing is as good as chromium. So there is also a lot of potential to in this area. Conversion coating. Anything regarding that part? Anything additional? Any of you work things similar to that? You are working cerium. Yeah. Cerium conversion coating. Yeah. I think people are also working with the lithium these days, right? Many. And they did a lot of work on the lithium based conversion coating. And I think quite successful, I think that one. And he used to come and present this Eurocore every year. Yeah, cerium is kind of probably a substitute for titanium zirconium. Then we came to the little bit into this contamination to the environment, right, which is coming from the buildings and different applications. And that area is becoming more and more important today because of the environmental concern. And we discussed about some of the research groups work. in this area, and how they are trying to bring some empirical equations so that they can have some predictability. If they know these parameters, they can get a little bit of predictability related to the metal release, and that way they are also trying to now involve in building constructions where they can make even advice and what material could be used and things like that. So again, showing the importance of the involvement of the corrosion engineers and like that in this. Anything related to that? Then we had about the recycling part. I think we focused on the aluminum recycling, but the recycling is important for all metals. There is a lot of things going on in steel recycling as well. And although the aluminum recycling has its own importance, that's basically because I told you that aluminum, unless until you recycle the aluminum cannot be used. In the cheaper applications, not aircraft, but the cheaper application, if aluminum has to be used more and more, then they have to use a recycled alloy, which means that all of us, metallurgists and corrosionists, we need to solve those problems. Either we cannot change the microstructure sometimes, but otherwise we have to make better protective measures and things like that. So there is a lot of things to do in that as well. Like you mentioned yesterday, when you came for the course, you understood that there is a lot to do in corrosion. You were saying yesterday, lot to do in corrosion. So it's exactly the things we can see that there is a lot of things where the corrosion and materials engineers have to involve. Maybe the recycling issue is much more easy to understand, but some of the other things what I presented, initially we don't think that there is a role for us to play, but there is a lot. Electronics, you think the electronic systems are failing, corrosion is failing. Normally we think that that's electronics, electrical engineers will take care of, but the fundamental mechanism, electrochemical and material related, we need to involve like that. And this problem will only increase because now these recycled material go to the car will come back, then get into the recycling again. So it is a chain of reaction. That's what is happening. Of course, this aluminum people also started thinking about that. So now they started using another thing called can to can. What it means that those materials used for a soft drink can, aluminum material, which will come back for the recycling, but it will go back also as a can. Because there the recycling issues and microstructure issues are a little bit less problematic. So like that. So that will not get into the automotive stream. All automotive alloys going into the automotive stream will come back to the automotive, things like that. So that way they can avoid the mix-up. So there are also strategies followed like that. But even then you will have more and more impurities, the alloys get downgraded. So this is going to be an issue. Then we had about wind turbine, low carbon technology, right? Wind turbine, we discussed about how the corrosion is an issue in wind turbine at different parts. It's a big structure. So it's very, very important to take care. So there are many parts, substructures and foundation substructures and tower, then come to the nacelle, there are many things inside. So we discussed about that. We also discussed in the last, today's, this one, that is how it is also important to do this proactive design and maintenance strategy for such kind of big structures. Carbon capture and storage, which is another area which we discussed, where there is actually here I should say the corrosion issues are just emerging. Nobody knows really what extent corrosion issues will be there and how it will affect the safety and all those things. It is really emerging, and any prediction we are doing now is wild prediction. It just is sometimes, like to get an idea about, for those who are operators and they are doing it, they need to have some level of idea, that is whether it's safe to inject and things like that. But otherwise it is just emerging. There is a lot of things to do in this. Then we talk about electronics, right, which is a little bit more different type of corrosion problem. And again, it's one of the important things today, and it's going to become more and more with electrified cars and things like that, because everything is all driving force is increasing. So as we have more and more electrified cars in India, you will start seeing also the problem. Then we have the last one, this. Anything on this? I just put this slide, that's all. Okay, so I think that's the last one. So just let me know anything more you want to discuss or